Dr. Neil Ferguson completed his PhD at the University of Natal, South Africa in 1996 and was offered a faculty position at the same department and institution. His main areas when he was a professor was studying quantitative swine nutrition, and he also had the cool role of working with lions, cheetahs, and crocodiles as well. In 2003, Dr. Ferguson moved to Canada to manage swine nutrition and modeling research, initially for Maple Foods and now Trout Nutrition. And during 2018, he took charge of global modeling science team within Trout Nutrition, and together with data scientists are generating innovative solutions for commercial application. He's been involved in establishing models as part of business culture within Trout Nutrition since then. Would you please help me in welcoming our speaker, who has a pre-recorded conversation and is going to join us for questions in the live session afterwards.
Good afternoon, ladies and gentlemen, and I'm sorry, I do apologize that I can't be there in person with you. I really would have liked to. It's a wonderful conference, and thank you, John, and your organizing team for inviting me. This is a wonderful opportunity. So nevertheless, I will share with you some of my thoughts on models and their commercial relevance. I'll look very briefly at just some background, look at some commercialization successes, then some examples, and then also look to some innovations, both near and far. I really enjoyed this quote by Nobel Prize winner Manfred Hagen. He said that a theory has only the alternative of being right or wrong, but a model has a third possibility. It may be right, but irrelevant. And I think this is particularly true for nutritional models that we use in commercial practice today. Just to give you a history, it's always good to reflect back where we've come from. Back in the 70s through to today, we've seen enormous changes in the concepts of modeling, going from the very early days of empirical modeling through to more theory-driven, mechanistic type models, and a bit of a cooling off period commercially. And now, of course, we get more into the big data wave where digitalization is really coming to the fore, particularly with management systems. And who knows what the future will hold as we go forward with this digital agenda and this hybridization of mechanistic and machine learning and AI type models. If we look very briefly at commercialization, by this I'm going to say when we look at the successful application of models, and by success I'm defining it as it brings about meaningful change, not only for a company and the customers, but really it brings about meaningful change for people, the people making money, and of course being sustainable. And at the core, I've highlighted a number of really fundamental principles of successful application of nutritional models. And probably one of the key ones is stakeholders, understanding the voice of our customer. Once you can understand what they really want, what they need, what the pain is, what keeps them up at night, that makes a lot easier in developing solutions to meet their particular needs. A culture, developing a model culture, is also important, not only within the company, but also in the business and the market segments that one works in. Veracity, of course, is hugely important. So that's both how accurate and the precision of the predictions. So that's a fundamental. One really needs to have very accurate, very precise models for use on farm, because if it's not, then of course the application becomes much more difficult to determine solutions for particular farms rather than very general concepts. People, huge. It's really having the right people, being trained correctly, who are motivated, who are passionate, who know the limitations, the weaknesses, but who are creative and who know how to use models to really bring value to our customers. And that's the last main point is the value proposition. These models really need to bring value not only for the customer, but also for the company to be able to be deemed as being successful in practice. So the point is really with the models is this really the integration of providing nutritional management and economic solutions. So it's combining all our resources from going all the way from NIR into these cost formulations, into the biological models, and of course economic components that allows a real circle of solutions. Another really crucial important of being commercially relevant is optimization. So by that I mean it's a combination of three components: the animal model, release cost formulation, and economics. And these talk to each other in an integrated and a dynamic way. And it's controlled really by what we would term some genetic evolutionary logic that really allows us to very quickly ascertain what are the optimum solutions. Now, these optimum solutions can, of course, be based on performance characteristics, so maximizing growth rates or minimizing feed conversion or costs or profits, maximizing profits. So depending on what the customer is really wanting to maximize or minimize. And then the objectives can be nutritional or they can be management-wise as well. So looking at amino acid requirements, for example, what should they be to try and maximize margin over feed costs? Or what are your the shipping management strategy to be able to, for example, maximize net profit? So the combination of the functions and the objectives that really bring value allow us to provide optimal solutions very quickly. So you can run hundreds and thousands of these solutions to derive a very specific solution for a producer with his particular packing plant that he's shipping his pigs to, with current raw material prices, etc. All of these can be done very quickly. So just to give you some examples, let's go through and look at some of the applications that have been used. This is one looking at ingredient variation. For example, in some customers in their mills, they check what's coming in to the mill. So what are the implications if, for example, you get a shipload of soybean meal that you're expecting at 46% crude protein, but when you actually test on delivery, it's only 42% crude protein. So you can do nothing. You can just accept the load and continue with your normal formulations. You can reformulate based on 42% rather than 46%, or you can accept the 42, but then demand a discount or reduce price per ton. So the model allows us in this scenario was we looked at formulating what's the performances at 46% soybean meal, and then the performances, the margin over feed costs, then the soybean meal at 42%. So if you did not reformulate, what the animal, the response, and the expected marginal profit. And then if you did reformulate, and at 42%. And what's clear is you can see there is a $3 per pig margin loss if you did not reformulate. So the cost of not measuring is pretty high. $3 a pig is high. For this customer with the 5,000 sow farrow to finish operation, it was looking at saving around $360,000 per year. The other thing you could do is ask, of course, for a $44 discount to offset that reduction in crude protein. Optimal requirements. This was a customer who wanted to optimize his amino acid levels to maximize his margin over feed costs. So in the model, we can optimize in a 4-phase feeding system, showing you what the model predicts, performances, looking at the margin over feed cost, expected to make about 72 cents a pig. When we actually ran it after close out one batch of pigs on the farm, took the data, and you can see we were pretty close. The reality was they made a margin over feed cost of 69 cents per pig. In this case, we could save, the customer was saving around $530,000. Planning, this was where you could use models to look at what was the consequence if you wanted to depop, repop, and make a genetic change because of any disease issues or change in your genetics. In the model application, we ran this looking at before situation, and then we would predict what the subsequent changes would be. So this was comparing as real benchmark data and what we predicted the changes thereafter would be. So this allowed this particular producer, who was a small producer, but allowed him then to make more sound financial decisions, whether he should or shouldn't do it based on what the anticipated improvement would be. So a year later, looking at his benchmark data, we have a look at what the data given, and the model was predicting no less than a 5% variance from prediction. So really gives confidence in producers to be able to use these tools to be able to not only look at nutritional, but also management and facility planning. Meat quality, we worked with a large packer who was shipping to Japan, and they wanted to improve the number of loins being shipped. And so they were focusing on the iodine value, mainly to reduce it to try and increase the levels of saturation so that the loin quality would be acceptable for the Japanese CTQs that they were shipping to. Using the model, we were able to show some alternative nutritional strategies, shipping, and of course we know there are some gender effects, but we were able to at least show that it's possible in their production loop to make a reduction of 11 iodine value points, which in reality could lead and did lead to 25% more loins being shipped to Japan. It's estimated that would be around 1 million. Of course, they would not inform us of the actual additional profit they made. Shipping, optimizing shipping strategies allows you, really important, depending on who your packer is. You can have looking at options of shipping based on optimizing your margins of return, more uniform pigs. And in this example, for this customer, we're able to show a reduction in overall pigs that you could make approximately $2.50 per pig more by just adjusting, in this case, just adjusting your shipping, making them heavier, and therefore maximizing on the grid the opportunities for heavier carcasses. So the solution is very specific to the packer. So those are just some examples. There are many more, but for the sake of time, I'm going to move on to looking at some innovations that have been coming forward over the last few years and really the potential that they have to drive us forward. Sustainability, I'm sure you're all aware, has become a really a hot topic, particularly looking at the incorporation of life cycle assessment software into biological animal models to be able to try and not only benchmark, but also to see other opportunities to reduce greenhouse gas emissions or any other environmental impact metrics that are particularly of concern to a producer, to a company, or to a country. The nursery, there's been some innovations there of how we can improve our accuracy of nursery predictions. Feed additives, another one, particularly around gut health. And then something more on the digital side, the development of apps, particular apps to be able to answer on-farm frequently asked questions regarding, for example, shipping weights, looking at growth patterns, looking at nutrient requirements for a particular farmer with his or her health status, their genetics, their nutrition supply, opportunities there abound, where you can very rapidly ascertain solutions to frequently asked questions. So just a little bit more detail when we talk about integration with LCAs or life cycle assessments. Typical models have inputs and outputs, where the innovation lies really is integrating this into animal biological models. In this case, the models would provide the formulations, the ingredients, the manure management, nutrient excretions, for example, that would then be fed into a life cycle assessment software. And I'll give an example here of SimiPro, where that information would then be the information from the LCA would be fed back and give you the sustainability or environmental impact metrics that are of particular concern to the customer or to the producer. And just to give you some examples in terms of animal production, we can see some of the benefits you can of improving health, a 5% reduction in CO2 emissions, looking at reducing mortalities, and other practical production issues that you could use if you were, for example, faced with carbon taxes. And it becomes really critical that you lower your levels of carbon emissions to be able to offset any of those carbon taxes. So not only on the nutritional side, but there are definitely opportunities within the actual production and on the farm to be able to make some improvements and reductions in climate change measures. This is another example, often a typical one, looking at replacing a particularly high soybean meal, so a higher crude protein-based diet, higher nitrogen excretion, with a lower soybean meal and using more synthetic amino acids. So you can see here a reduction in almost 2.5% of the carbon emissions through both the feed and a little bit on the manure side. Feed additives, opportunities there, for example, where we know that how the additive is actually working in models, and in particularly our model, we do have the capabilities of looking at gut health additives and how they impact in the biology of the animal, which I'll talk about in the following slides. But we can see here, getting some idea of the impact of an additive. It's complicated. It's not only related to the additive, but of course the health status of the herd. So where they are commercially below average, the health status, you get a better return for feed additives than, for example, you do with better health status. And that, of course, will impact on the carbon footprint values as well. On the nurseries, some key factors here: post-weaning growth modeling. We see differences in growth patterns appearing immediately after weaning, compositional changes. We see voluntary feed intake reductions. So this complexity that we have associated with nursery, we've now been able to, with more data, actually incorporate these into models that have fairly meaningful opportunities in managing a nursery program, but also with a fair degree of accuracy. So for example, here you see this was comparing some trial data from commercial conditions, poorer health, looking at the model predictions are the big black dots versus the line is the average of these commercial farms. And you can see some of the variation around that. But for the most part, within around 5-6% variance of prediction versus actual. And similarly, we see for average health and then for very good health, where we're looking under more research-bound conditions. And so predictions really are, for the most part, well within one standard error of the mean. So this allows us then, for example, one of the opportunities is when you run to an optimization program, you can optimize for growth, feed efficiency, or costs, for example. So this is an example of a 4-phase feeding program in the nursery. You can see whether you're maximizing growth, whether you're minimizing feed conversion, or whether you're minimizing costs. You can see for higher growth, you would go for more of the diet 3 and less of diet 4, whereas for lower costs, you would go for more of the 4th diet and less of the 3rd. Sounds logical, but to actually get the amounts and then to see the benefit in terms of monetary value is what really helps us drive that decision-making process. Additives. Just a quick word on here. Again, some innovations where we've looked at gut health additives. So what is the actual mechanism by which these additives are having the effect in the gut, microbial, gut health, the GI tract health, and immunomodulation. Microbial, affecting microbial population will impact on the ability of the pig to express its potential and its health status. The GI tract improving will improve nutrient digestibility. And of course, immunomodulation helps with reduction of immune activation or improving nutrient partitioning into growth away from maintenance. So if we can better understand these concepts, for example, understanding and modeling the impacts that the additive has in terms of its contribution towards being antimicrobial, its contribution to improving gut health or immunomodulation, then from that, we can ascertain the metabolic effects and predict the impacts on the animal in terms of its ability to express its genetic potential. So not modifying feed intakes or average daily gains. No, you just influence its ability to express its potential, or you're reducing the maintenance requirements, or improving the nutrient digestibility, and therefore allowing the model to predict the subsequent performances. And this is just to give you an example roughly of the categories of additive and where they are likely to be having their impact in terms of gut health. So giving you a commercial example here was a customer on his nursery week 1 to 6 performance, average daily gains, feed intakes, and feed conversions. When we look at the additives now on the model side, if you provided no additives, this is what the model would predict. If you looked at what could be the potential of maximum benefit of the additives, so as it were, throwing the whole kitchen sink in of additives, you can see there is opportunities for significant improvement. And then the model showed that if we use the customer's additives, you can see the responses between actual and what the model predicts is very close. And we can then see what the range of the additive effect is. So with this kind of level of accuracy and prediction allows us then to see on farm which farms would benefit from using additives and which farms wouldn't. So the higher the health, the better the management, the better the overall viability, robustness of the pigs, then the less the impact these additives will have on the performance of the animals. Another example for a large commercial integrator looking at replacing antibiotics in the nursery. So this was a case of looking at some performances and costs and looking at a medicated program. So the green line, this is what their benchmark data was. So this is using a medicated program, which they were using. And then when we added the additives, we could show the improvements that could be made from using the benefits of the additives when you're using no antibiotics. And the customer in this case did confirm that the observations that we recorded were very close to what they actually saw when they switched from using antibiotics to using no antibiotics. So again, it's just a tool to allow to make decisions once you have this degree of confidence the customer is happy with what you're predicting, allows one then to make other predictions for other farms. So if we just look ahead of us, what do we see? We all know there's been a huge wave of big data and a digital agenda. The volume of data now being generated from a number of technologies, from farm equipment, has led to the whole data science and machine learning entering more into the livestock industry. So with that, of course, there are risks with these disruptive technologies, both commercial and technical risks, which one needs to be aware of in order to maximize the opportunities. If we look at the digital context of models, so it's large amounts of volume of very variable data coming in. So you have these different levels of being able to capture the data, use artificial intelligence, then develop machine learning models from which even further you can develop what they call deep learning models, where you can really start integrating a decision-making process in, for example, a precision livestock feeding program. The outputs are typically, though, black boxes. You don't really know what's happening in these models. They tend to be weak on the biology side, and we know that, of course, machine learning models have no common sense. They just work purely off statistical, purely off mathematical functions. They don't have the ability to make common sense decisions. So what's our digital presence in the animal nutrition side? Well, quite frankly, it's pretty dismal. Looking at publications from 2011 to 2018, less than 0.6%, less than 1% were actually animal related publications on using digital technologies in the animal nutrition sector. So there are opportunities, so not only for machine learning models, but also for mechanistic models. They become enablers, so they enable one to look at a number of different situations on farm to help customers make better decisions and to come up with more meaningful management and nutritional strategies. Precision feeding, of course, has been around for a while, but it seems to be gaining some attraction. So we can look at models to make real-time decisions regarding how much an individual pig should be fed based on its historic growth performance. The visualization and monitoring is starting to grow as well. So providing cameras, sound equipment that can pick up sounds, can visualize heat images or actual pigs themselves. So you can start looking at the animal air quality as well as feed. You can monitor feed and also health, picking up, for example, coughing, the levels of coughing and the volume of coughing. There's software that is now developed to be able to give indications when maybe it's reaching a certain threshold and there might be issues worth looking at. Forecasting is another one. For example, looking at prices, nutrients, and even diseases. Are there these patterns? When should you have intervention strategies, prevent rather than cure? Optimization from economic point of view, performance and whole systems. When all the data is collected, you can combine biological models with more system type models to really look at a whole, optimizing a whole system, the whole flow from the sow right the way through to the slaughterhouse. And then opportunity analysis. This is the really fun part one, where you can look at what if scenarios. You can try and make improvements on farm without spending a dime or without any potential loss in production. And this really, when you have good models, good prediction, high levels of accuracy, really becomes from a commercial point of view, a real win-win. There are some concerns you need to watch out with this whole digital disruption, particularly on the big data side, that one doesn't overpromise and underdeliver. There's often high expectations of data. So is this going to be a niche versus a norm type situation? Yeah, the verdict is still out there. Complexity, the investment costs. Of course, we know with the whole infrastructure, who owns data. When you look at the value proposition, what is the customer actually benefiting? What is the company benefiting by providing that data analytics or providing the services back to the customer? And then, of course, the agenda. Is this more of a IT, more of a digital takeover than a truly animal nutrition technology improvement? Yeah, so that depends very much on how the models are structured, designed, and what their value proposition is. Hybridization is a concept I'm sure some of you may not have heard, but really this is the bringing together, collecting and compiling enormous amounts of data from external data sources into a data lake, from which then you can have models. Some of those models can be biological, more mechanistic, so they're not dependent upon the data. They are more driven by the actual metabolic processes in the animal. Then you can combine it with the machine learning that you obtain from all the data analytics from the data lake that you get. So this hybridization of technologies, which then allows very meaningful deliverables from very simplistic nutrition formulation performance to more optimizations, subject matter applications, and in system optimizations. So the whole range, the whole suite, depending on the digital savvy of the customer. So from digitally naive or digitally very protective customers through to very advanced digitally enabled companies who would like to partner. So you have the whole continuum, the whole spectrum of data users and customers which you can develop models to meet their particular needs and requirements. Just to give you an example on hybridization, one that has been and is in practice, the monitoring of weight by using imaging and scales. In the barns, some use scales when they stand to eat, they can be weighed. Others actually use cameras to detect from a top-down and obtain the estimates of the weights of the animals. From all the sensors in the barn, from health, temperature, relative humidity, space, some management inputs into the model, dietary inputs, for example. You can use the actual animal model to determine what should be the target weight. Then you can compare it with the monitoring of an individual weight. And from that, you can then derive what would be the amount that you would feed that particular pig to keep making sure that it's on track for its target weight. And you can then develop, if the feeds are blends of two feeds, you can develop the right blend for a given age and for a given individual pig and how it is growing in terms of lean growth rates. From this data, you collect the data, you can do data analytics from which these can be used to feed back into the animal model. You could use machine learning to help improve the animal model with diagnostics and with inputs. And then, of course, just provide the advice to the producer on what and where they should be looking at to make changes to try and improve the whole production system. The apps is another innovation coming up more and more. This, for example, is just optimum slaughter weight. So you would have basically on the phone some very simple certain inputs that the producer can put in that they would know. And then, for example, the model would be able to, using the APIs, the app would access the models to be able to determine what the ideal target market weights should be for that particular packer for that processing. And also then could show what could be the additional revenue one could make based on their existing system. Another example could be looking at generating farm-specific curves. So you could put a start weight, an age, and an end weight. You could generate the curves and then actually have a look, what are the potential curves? What's the variance around there that I would expect? So then, for example, you could say, I'd like to know what should I expect the weights at, say, 100 days of age to be? And you can get an estimate as well as the range. So it just helps make decision-making on the farm a lot easier with these type of very quick apps that are making use of the power of more sophisticated models. So in conclusion, then I would just like to say that, depending on how the model is designed, will define to a large extent its commercial relevance. It's really important that they are designed to make money. They should be business-centric rather than just purely nutritional-centric. They should have a very significant financial and economic bias to be able to really be used by farmers to make meaningful financial decisions. And they should have better biology. The better the biology, of course, the better the model prediction would be. And that's where assimilating data and biology could work in a symbiotic relationship to really be able to provide opportunities for real innovation. But also being aware that one needs to know the commercial and the technical risks before one embarks on developing these new digital technologies. So with that, ladies and gentlemen, I'd like to say thank you very much, and I would be more than happy to answer any questions that you might have. Thank you.
All right, while we're getting Neil pulled up, we'll have the microphones going around with the questions. Can you hear us?
Hello?
Hello?
Awesome. Thanks for that great presentation. Are there any questions for our speaker? Yes, John?
All right, here we go.
Thank you. Okay, thank you, Neil, for that real comprehensive overview of models and their potential applications. The question I had was, as I listened to your presentation, the sense that I had was that you see a great use of the model to optimize a production system based on their performance. So you were talking about poor health models and so on, and defining the feeding program that would maximize net income given that performance. So that's one role of the model, but is there another potential role for the model to say, rather than feed down to the existing performance of the farm, what are the implications if we feed up to what those pigs really should be capable of, whatever is the constraint? I certainly see the value in feeding to where they are, because that maximizes your return over feed cost and other income, but it also kind of guarantees that you can't get any better because you're feeding to that level of performance.
Yeah, good question, John. I think one of the points to realize is that the models need to be stochastic. They need to be population models to be able to allow you to actually look at, as you say, feeding up. The optimization process will allow you to look at different objectives and different functions. For example, you don't have to necessarily be feeding down. You may be feeding to satisfy the requirements to meet 70% of the population's requirements. And then you can see with optimization, is that actually going to give you a better overall response than you currently have? So you are by no means limited to developing strategies that are just meeting where you're at now. This is the real advantage of models, is that you can have a look at, if I want to really improve and drive feed efficiency, I'm going to develop, you can develop feeding programs that will drive feed efficiency, but at the same time, you can measure the cost that that's going to incur. And that's crucial, because while you might really push to get a higher growth rate, higher throughput, you need to know that there would be a consequence on the cost in the diets, for example. So this is where models really come into their own. They take into the whole, everything, the throughput. If you're growing faster, you can get more pigs through a barn, but at what cost? And so I think this is where these sort of optimizations allow you to be able to push beyond what your current performances are.
Great, thanks very much, Neil. I don't see another question right now, so if I can ask another question for you, Neil, and that is, it's the role of the model in education and training. Do you see, would it be appropriate to use your models at the undergraduate level? Obviously, they could have a lot of application at the graduate level, and just a quick comment on what you think their role could be in training.
Yeah, John, good question. I think it's huge. And we've been doing some pilot trials with the University of Guelph. So it was in a fourth year undergraduate course related to nutrition and formulation in swine. And so we basically allowed them access to the tool, and they were then given real case scenarios. For example, on farm, this particular farmer had these issues, A, B, C, D, and they gave the diets, they gave the performances, the benchmark data, and they would basically tell the students, you go about and try and find out what the issue is and how could you, what would your solutions be? So I think it's huge. The opportunities to actually allow graduate or undergraduate students to certainly look at production systems, making changes and seeing the impacts, which for some undergrad students have never been on a farm, this becomes huge.
Neil, this is Mike Tokash. I appreciate your presentation. Models have been around for an awful long time, and there's been, I've always been curious, and I've never fully understood why we've never been able to really see them put into practice, particularly in the United States, the way that they have the opportunity to be, and especially for the mechanistic models. And I'm curious on what some of your thoughts on why we've never seen them really be utilized to their potential.
Yeah, Mark, a good question. You've really put me on the spot with mostly a US audience. I'm not here to criticize you guys at all. Each to their own. You guys know your markets better. It may be that, to Dean's earlier point, heavily corn, soya-based diets with DDGs, that maybe there's people get into a nice groove that really works for them. And in some cases, you may well be at your optimum. And therefore, models have limited value in terms of adding nutritional value. Where I do think, there is this perception, and it probably goes back, I guess, to the late 80s, early 90s, when models really started coming into practice in the industry. They got a really bad rap because, to be honest, they were very poor in prediction, and so had very little value. People tried them, they burnt their fingers on them, they left. But I do think with the new generation coming and people more technology savvy, these tools really start coming in their own when you start looking at systems and more on the looking at production management, not just nutrition. So it's really looking at stocking densities. It's looking at pig space, feeder space. How can I maximize or optimize the system that I want to get throughput, but I realize I'm overstocking? So I'm getting impacts on growth and performance. It's these where you have this sort of multi-factorial approach that I really think in the US models will start to take more of a role. I think also a modeling culture, because of the history of models, I think there's been a reticence to really embrace them again. The other one, of course, is most of the large operators have their own in-house, I would call them models. They are predominantly, I would say, fitted statistical models to a lot of data. You have to be careful, fitted versus predicted. There's quite a big difference. So it might work for a particular data set, but as soon as you go outside of that data set or onto a different farm, different barn with different health conditions, the wheels fall off. So that's where there is some, again, people more reluctant to embrace models because of that, as opposed to mechanistic models, which you should not be limited to by that. So Mike, a long-winded story. I think it really is it's about embracing technology and what it can really do for you and your customers.
Awesome. Thanks for that. We are done with this session, so we'll take a break. We'll go out these doors, and we'll start at 3:30 p.m. sharp. Thank you, guys. Let's thank Neil one more time. Thank you, Neil.